Good morning, my dear students. Today I am going to explain what is meant by DFT, how we are going to find out DFT by using DIT-FFT algorithm. First of all, let us discuss what is meant by DFT and why we go for DFT. So I am going to explain the importance of DFT. We know that the abbreviation of DFT is Discrete Fourier transform. Fourier transform. Except this discrete, remaining about Fourier transform we have studied in our second year signals and system subject. So let us recall whatever we have studied in second year signals and system subject. Fourier transform. A Fourier transform is a method. A Fourier transform is a method which is also called as which is also called as transformation, which is used to represent a continuous time signal onto the frequency domain. How we are going to represent this Fourier transform? Whatever we have discussed, the importance of Fourier transform, or let us draw one block and consider it is a transformation. What type of transformation is Fourier transformation or Fourier transform? By applying a Fourier transform onto the continuous time signal, we will get frequency domain representation of the continuous time signal. That frequency domain representation of continuous time signal is represented by x of omega. Okay. This x of omega is represented by integral minus infinity x of t into e to the power of minus j omega t into dt. It is the representation of Fourier transform. A Fourier transform is a method. Which is also called as transformation, which is used to represent a continuous time signal onto the frequency domain. Okay, from which we can also find out inverse Fourier transform. So for inverse Fourier transform, let us consider this one is I of t inverse Fourier transform. For this inverse Fourier transform, what is input? Whatever we got after applying Fourier transform onto the time domain signal, we will get Fourier transform output. It is a frequency domain representation. So for this inverse Fourier transform, input is Fourier transform output, that is capital X of omega. And what is the output of I of t? Small x of t. Okay. So here a small x of t, that is a continuous time signal, and a frequency domain output capital X of omega. These two are the Fourier transform pair. That is, by applying a Fourier transform onto the continuous time signal, we will get a frequency domain output which is represented by capital X of omega. And by applying inverse Fourier transform to the Fourier transform, we will get continuous time signal as a output. That's why here continuous time signal and Fourier transform of the continuous time signal, that is X of omega, these two are the Fourier transform pair. Let us write down the equation for X of t. For this, we are going to multiply with particular time, that is 1 by t integral minus infinity to infinity capital X of omega into e power j omega t into d omega. What type of omega it is? It is d omega. It is the equation of inverse Fourier transform. Now let us discuss about discrete Fourier transform. Discrete Fourier transform. What we have discussed about transform, Fourier transform? A Fourier transform is a method which is also a transformation technique which is used to represent a continuous time signal onto the frequency domain. అసలు ఎందుకు వెళ్ళాలి సార్ ఫోరియర్ ట్రాన్స్ఫార్మ్కి అంటే అన్ని సిగ్నల్ మనం టైం డొమైన్లో అనలైజ్ చేయలేం. సో టు అనలైజ్ ద సిగ్నల్ సమ్టైమ్స్ వీఆర్ గోయింగ్ టు కన్వర్ట్ ఎ టైమ్ డొమైన్ సిగ్నల్ onto the frequency domain. Okay, so now let us discuss about discrete Fourier transform, which is also called as DFT. It is a shortcut of discrete Fourier transform. Okay, so for discrete Fourier transform, what is input? Let us consider this one is a discrete Fourier transform. For a discrete Fourier transform, what is input? The input is discrete time signal which is represented by x of n. If in the brackets, if we have the n, that is n sequence, that is discrete time signal. And by applying a discrete Fourier transform to the x of n, we will get what we will get? Discrete Fourier transform output, that is frequency domain representation of that x of n input sequence. We know that, as we have discussed in the previous video, we have done problem on DFT and IDFT. So at that time we have used the formula, that is a discrete Fourier transform can be represented by, here input signal is discrete time signal. So for a discrete time signal, instead of using integral, we are going to use a summation, and here the sequence is n sequence, for which we are going to use n is equal to 0 to capital N minus 1 x of n into e to the power of minus j 2 pi k n by capital N. it is a discrete Fourier transform DFT equation. Now let us write down the equation for IDFT. For an IDFT we are going to multiply 1 by n and here the summation. That is, if it is input signal is a discrete time, then output also, that is a frequency domain representation of that discrete time signal, is also discrete one. That is the reason we can call it as a discrete Fourier transform. That is a Fourier transform of a discrete time signal is called as a discrete Fourier transform. So output is also discrete one. That is a frequency domain representation. Here output is x of k and input is x of n. What type of input it is? A discrete one. That is the reason here we have used summation. Likewise, to get x of n as an output, we are going to apply IDFT. We are going to apply IDFT on this frequency domain representation, that is DFT. So that is for which the input is DFT to get the discrete time signal by the IDFT. So that is like this, for which the input is capital X of small k and output is x of n. Here the summation range k is equal to 0 to capital N minus 1 x of k into e to the power of j 2 pi kn by capital N. It is an equation of IDFT. Okay, thank you.